This video is provided as supplementary material for courses taught at Howard Community College. And in this video, I'm going to talk about triangle congruence. And rather than just give you the rules for triangle congruence, I want to show you how you can derive them logically. So let's get started. I've got 3 sticks here. I'm going to take the sticks and arrange them into a triangle. Now, if you think about it, if you've got these 3 sticks, and their lengths are never going to change, there's really only one triangle I can make with them. If I had a second set of sticks and they had exactly the same lengths as what I've got here, I would end up making exactly the same triangle. This concept is going to give us what we call side-side-side congruency. What that says is this: if I've got 2 triangles, let's call one triangle ABC, and I've got another triangle, we'll call that DEF. And let's say side AB is exactly the same length as side DE, like 2 sticks that are the same length. So they're congruent sides. Let's say side BC is congruent to EF. It's like 2 sticks that are exactly the same length. And let's say that side AC is congruent to side DE. If we've got that situation where we've got 3 pairs of congruent sides, then those 2 triangles are going to be congruent. So this is called side-side-side congruency. Okay? Now, after that we have something called side-angle-side congruency. We can think of it this way. I've drawn 2 figures. One I'm calling ABC and the other I'm calling DEF. They're both made up of a pair of line segments that meet to form an angle. And angle B is congruent with angle E. AB is congruent with DE. It's exactly the same length. BC is congruent with EF. It's exactly the same length. Now, if I connect AC to form a triangle, I'm connecting it with a straight line. And I connect DF to form a triangle. I connect that with a straight line. Those 2 straight lines would really have to be exactly the same length because I've taken 2 identical figures and I've done identical things with them in drawing those 2 straight lines. So therefore, these 2 triangles must be congruent. This is going to be called side-angle-side congruence. I've got a side, a pair of sides that are congruent, and then an angle, pair of angles that are congruent, and another pair of sides are congruent. Now that angle has to be between those 2 sides. So these angles are called the included angle. So if we've got 2 pairs of sides that are congruent, and the included angle is congruent, then we've got side-angle-side congruency, sometimes just called SAS congruency. Okay? We've also got angle-side-angle. So I've drawn figure AB and figure DE. They both end in angles, angle A, angle B, angle D, and angle E. And then there's a line segment connecting angles A and B and connecting angles D and E. Angle A and angle D are congruent. Angle B and angle E are congruent, and the line segments connecting my angles are congruent. Now, if I take these angles, if I take the rays going off of angle A and angle B and extend them, they're going to meet somewhere. I'll call the place where they meet point C. And I'll do the same thing for the ray at angle D and the ray at angle E. And I'll say that they meet somewhere, and that's F. Now once again, think about this. Figure AB and figure DE were identical. When I extended their corresponding rays, they must be doing exactly the same thing. They must be meeting in places corresponding places that are in exactly the same place relative to the rest of the figure. And they must be forming exactly the same angles. So that means these two triangles that I've formed, ABC and DEF, must be congruent triangles. So this is called angle-side-angle congruence. What it says is, if we have two pairs of congruent angles, like pair A and D, and pair B and E, and the side between them, the included side between them, those sides are also congruent, then we're going to have two congruent triangles. So this is angle-side-angle, or ASA congruence. And the last congruence we have is angle-angle-side. And here's how that works. Here I've drawn kind of like the skeleton of two triangles. The triangles will end up being ABC and DEF. I've got angle A and angle D, and they're congruent to each other, but they're not connected to anything yet. Angle C and angle F are also congruent to each other. And then side BC is congruent to side EF. Now, let's draw some dotted lines to kind of fill in the triangles. I can show that these two triangles are congruent. And here's how I can do it. I know that the angles, the sum of the angles in any triangle is 180 degrees. If I've got two triangles, and I've got two pairs of identical angles, then the remaining two angles, in this case B and E, must be identical also. Okay, think about that in terms of angle A and angle B and angle C have to add up to 180 degrees, and angle D and angle E and angle F have to add up to 180 degrees. Okay, if A equals D and C equals F, and the sum in both cases is 180 degrees, then B has to equal E. Okay, so I know that angle B is going to be congruent with angle E. Well, now what I've done is create a situation where I've got angle, side, angle. I've got angle C, and in the other triangle, angle F. I've got a side right next to that, CB. For the other triangle, it's FE. And then another angle, angle B, and angle E. So these two triangles must be the same because of angle-side-angle congruence. But I started out just knowing that they had angle, angle, side. So that means I can say that there's a congruence that we'll call angle, angle, side congruence. If you have two triangles, a pair of congruent angles, another pair of congruent angles, and then a pair of congruent sides that aren't even between those two angles. So we've got angle, angle, side. These triangles are going to be congruent also. Okay, so that's your four basic rules for triangle congruence. Side, 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 angle, side, angle, and angle, angle, side. You might want to play around with this a little bit. Make sure you can recreate it for yourself. If you want to memorize the rules and so on, that's fine, but you can just work this out in your head pretty quickly once you get the general idea. Okay, I hope this helps. Take care. I'll see you next time.